This next section, which is 0, 2, is really a review. It's on multiplying polynomials. So we have FOILing and distributing. Remember, FOILing is just another way for distributing. So let's look at the first example. We have a binomial, 2 terms, times another binomial, 2 terms. So that's where we FOIL, which again is distributing. So we'll do x times 4x, the first, that's the f in FOIL. That gives me 4x squared. Then we do the outside, x times 1 is positive x. Then we do the inside, 4 times 4x is positive 16x. And then the last terms, 4 times 1 is 4. Once you distribute to everything, we then combine our like terms. So our middle terms are like terms. So our final product is 4x squared plus 17x plus 4. You try 2, 3, and 4. Remember, multiplying, we use distributing. All right, let's look at 5. We'll set this up together. Here's a word problem. We have a rectangular garden that's 20 meters by 30 meters. And the garden is surrounded by a path of uniform width. So what that means is all around this garden, there's a path that's the same width all the way around. Okay? So we want to write an expression for the dimensions of the garden and the path. So what we have here is a garden that's rectangular, okay? It's 20 by 30. And then around it is a sidewalk. I'll do my best to sort of draw that with uniform width. So around it is a sidewalk. So we want to know what are the dimensions of this new figure. So I'll use orange here. We don't know what this sidewalk is, but because it's a uniform width, we know it's the same amount everywhere. So that means from here to here is the quantity x. And if that's how it is up above, that means it's the same thing here, and the same thing here, and the same thing here. So each distance around is going to be x amount. So we'll define that. X represents the width of the sidewalk or path. Okay, so what are my new dimensions? Well, originally the garden was 20 feet wide. Well, now we have a path on each side. So that means now the new width is going to be 20 plus 2x. Originally was 20, but there's a path on each side. So what does that mean for length? So length is going to be 30 plus 2x. So those are the expressions for my dimensions, 20 plus 2x and 30 plus 2x. So what I want you to do is part B. Write a polynomial that represents the area. So remember, how do we find area? Remember, area is length times width. So keep that in mind and go ahead and write an expression for the area of the garden. All right, so that was multiplying. Let's review some factoring. So you have learned just about all of the factoring skills necessary, except for 2 skills. And then, of course, looking at some more in-depth ones where we use a combination of them, maybe a little rusty that we need to fine-tune. So let's review some of our factoring skills. The first thing, no matter what we do, is we always check for a GCF first, okay? No matter what, whether there's 2 terms or 10 terms, always check for a GCF. What does GCF stand for? Greatest common factor. So if you look at the example to the right, we have 3x cubed plus 6x squared minus 15x. And if I look at that trinomial, I look at what they have in common. And they have in common a 3, and they all have an x. So that's why we pull out a 3x. And then what's left is x squared plus 2x minus 5. So always check for GCF. Now, if it's 2 terms, what we look for is a difference of 2 squares. So remember perfect squares, obviously if we see a squared symbol, but things like 4, 9, 16, 25, those are all perfect squares. So a difference is when we have subtraction of those 2, we take the square roots of the terms and it becomes a minus b, a plus b. And again, there's an example done for you. However, what I want to focus on real quick is the new ones. And I'm going to put a little star next to them. The difference of two cubes and a sum of two cubes. So this one is relatively the same. It's just the signs are different. But cubes are where we have, and I'll jot some of them down on the side. Some of our perfect cubes are obviously 1, but then we have 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and so on. Okay, so you want to be familiar with some of the perfect cubes so you can recognize them. So if I have a difference of cubes, we take the cube roots and we pop them in the first set of parentheses. If it's a difference, it's a minus b, aka the cube root of each being subtracted. If it was a sum, we do the cube roots added together. Then we square the first cube root. The last term is the square of the last cube root, and the middle is the sum of the two cubes. Okay, so let's look at an example. We have x cubed minus 8. So the cube root of x cubed is x, and the cube root of 8 is 2. So therefore, the x and the 2 are what I'm popping into the formula. So since it was a subtraction, and we have x minus 2, then we square the first term. So it was x, so now it's x squared. The product of the two, x times 2 is 2x, and then the square of the last term. So 2 squared is 4. And the same example below, but this time it's addition, so we see some sign changes. We have a plus in the first parentheses and then a minus and a plus. Okay, so I'll have you practice that, and of course we'll continue with more practice. The next ones are all ones that you have done before. Perfect square trinomials, a trinomial with a leading coefficient of 1, and a trinomial with an actual coefficient. Now for those trinomials, guess and check is often a faster method. However, as the numbers get to become larger and even numbers that have a lot of factors, sometimes it may take a little longer to do guess and check, so you can use the factoring by grouping method, which I'll discuss in examples. And then lastly, if we have multiple terms beyond 3, right, 4 terms or even more like 6 terms, we can use the grouping method where we group 2 out of a time or 3 out of a time. Okay, so let's do a couple examples together, and I'll have you try some of them on your own as well. So why don't I do number 3. So number 3 says 16x squared minus 81. So right there, the first thing I do is a GCF. Well, the factors of 16 are 1, 2, 4, and 8. 16. Does that go into 81? No. So there's not a GCF. So instead, we recognize, okay, there's 2 terms. So what is this? Is this a difference of 2 squares, a difference of cubes, or neither? And if I look, it's a difference of 2 squares. So the square root of 16x squared is 4x, and the square root of 81 is 9. So these are the 2 terms I'll pop into my parentheses. This will become 4x minus 9 times 4x plus 9. And always check to make sure you can't factor anymore, and I can't. Now remember, a way to check, and I'll just jot this down, is to actually multiply back through. So if I multiply those 2 sets of parentheses, I better get the original answer. Okay? Let's move on to number 4. Number 4 has 4 terms. So when there's 4 terms, we're going to factor by grouping. So in this case, I'm going to look and I see, all right, these first 2 terms, I see they have something in common, a q. So I'm going to factor out a q. What's left is a p minus 2. The second grouping, I'm going to include the symbol, and I know they have a positive 2 in common. So I make sure to take out that symbol with it. So positive 2. And I'm left with p minus 2. For factoring by grouping, you know you did it right if you have a matching set of parentheses. So we do. So my final product is one of those matching parentheses, and then the part that was on the outside, q plus 2. And again, how can we check to make sure we did it right? Is you can FOIL it through. Okay, how about number 6? So for number 6, I see I have a trinomial. But recall, the first thing to always do is check for that GCF. And so for these ones, I see even numbers. So that definitely means they have a 2 in common. Do they have anything else? No, right? 6's factors are 2, 3, and 6. That doesn't go in. So we're going to take out a 2, and I'm left with 3x squared plus 10x plus 8. So from here, I'll look to see, can I continue factoring this trinomial? And so this trinomial has a leading coefficient. So I can use factoring by guess and check, or I can use factoring by grouping method. Okay, and I'll do both. So for our factoring by grouping method, what I'm going to do is look at the first two terms. Sorry, the first term and the last term. So I say what multiplies to 24 and then adds the middle term, which is 10. So factors of 24, 2 times 12, well, that doesn't add to 10. 4 times 6, that does. So I'm going to not forget about my GCF of 2. I'm going to bring that down to remember about. But now I'm going to rewrite this. I'm going to leave that first term of 3x squared, and I'm going to break the 10 into a 4x and a 6x, and then we have our last term. Now I have 4 terms, which I can factor by grouping just like we did in the previous problem. So once I group, we take out the GCF. The first grouping has an x in common. We're left with 3x plus 4. The second grouping has a positive 2 in common, and we're left with 3x plus 4. So now we have our GCF of 2 that we originally took out. We have the 3x plus 4, the matching set, and then the part on the outside, which is x plus 2. And there's my factorization. Now, if I wanted to do this problem originally with guess and check, I'd still have my GCF out front, but then I jump to setting up 2 sets of parentheses. Now, we know the first term was a 3x squared. So when I'm doing guess and check, it's working backwards with multiplication. So I'm asking myself, what times what could give me a 3x squared? And that's pretty straightforward. The only way to get a 3 is to multiply 3 and 1. So that's why I know a 3x can go here and a 1x can go there, or vice versa. That doesn't matter. Now, all the signs are positive, so I know I'll have plus signs. And then I know the last 2 terms in these parentheses would have to make an 8. So to get an 8, it's either 1 and 8 or 2 and 4. Well, if I put a 1 and an 8, remember that would now give me 24x and 1x, which would make a 25x. However, we only have 10x. So that's why that's the guess and check part. We don't want to use 1 and 8. Instead, we want to use 2 and 4. And again, how do I know which spot to put them in? That's where the guess and check part is to sort of FOIL out and make sure we have them in the right spot. All right, let's do 2 more together, and then I'm going to let you go back to do the other ones on your own. So number 8, this one here is a binomial, but there's not a GCF. So that means, is it a sum of cubes or squares or neither? Well, remember, when I have a sum, we can only have a sum of cubes. There is not a sum of squares. And the good news is I see cubes. So what we want to do is take the cube roots. Cube root of the first one is x. The cube root of the second one is 4y. Remember, not 8, okay? A square root would be 8, but we're doing cube roots. So now I take these 2 terms and I pop them into the formula, which is above in the chart. And what it said to do is to take the first cube root, then plus the second cube root. Then for my second set of parentheses, we square that first one. So it was an x, so it becomes x squared. We do the product of the 2, so x times 4y is 4xy. And then we square the second one. That was 4y, so don't forget to square the whole thing, becomes 16y squared. And you're done. Okay? The last one I want us to look at is number 9. And you can do this problem in a couple ways. This one you could FOIL out, right? We could multiply 2 minus x all squared, 2 minus x, 2 minus x, and then distribute and so forth, and break it down to a trinomial. Or because I see these matching term groupings showing up, more than once, I'm going to use something called U substitution. And to make this look a little prettier, that matching group I see, I'm going to call U. So 2 minus x is going to be called U. What that means is I can go replace this now with 2u squared minus 9u plus 9. Because I said u is 2 minus x. So wherever I see a 2 minus x, I'm going to put a u. Now I see, okay, this doesn't look so bad. Can I factor this trinomial? Is there a GCF? Nope. So can I factor by grouping or by guess and check? Yeah, absolutely. Okay, so again, you have your two methods, your choice, what you want to do. I'll do the grouping one just to give people practice with that, since that one has the work, but if you can do it with guess and check, jump to that. So this is what will multiply to positive 18, right? 2 times 9 is 18, and what would multiply to negative 9? So what is that? I need a negative 9, so that's going to be negative 3 and negative 6. So I'll write this as 2u squared minus 3u minus 6u plus 9. Now we take out a GCF. In the first grouping, there's a u in common, so we're left with 2u minus 3. In the second grouping, I'm going to take out a negative 3, and I'm left with 2u minus 3. We match, woohoo! So my factorization is u minus 3 and 2u minus 3. However, we're not done. My original problem didn't have u's, it had x's. So remember, u is 2 minus x. So where I see a u, I need to go back and put in the 2 minus x. So I have 2 minus x minus 3, and then 2 times 2 minus x, whoops, minus 3. So we need to clean that up. That first one will become negative 1 minus x. The second one I need to distribute, so that really becomes 4 minus 2x minus 3, which will become 1 minus 2x. And there you have your final factorization. So go ahead and try the other problems using those skills, and we'll continue practicing more in class.